Lesson 13, State as a Snapshot. 1. State as a snapshot. At first glance, state variables in React might look like ordinary JavaScript variables that you can freely read and modify. But that's not exactly how they behave. State in React works more like a snapshot in time. When you set a new state, you're not changing the existing state variable directly. Instead, you're telling React to prepare a new snapshot and then re-render the component using that new version of the state. 2. Setting state triggers renders. When we think of user interfaces, we often imagine them changing directly as a result of an action, like clicking a button. In React, the mechanism is a little different. When you set the state, you're not immediately updating the visible UI. You're requesting React to re-render the component. For example, when a user presses a button to send a message, setting the state tells React to re-render the component with updated information. During this re-render, React uses the new value of the state to decide what should appear on the screen. Here's what actually happens behind the scenes. The event handler runs. The state is set to a new value. React schedules a re-render. The component re-renders with the new snapshot of state. This is the key to how React keeps your UI synchronized with the data. It always re-renders using the most recent snapshot of your state. 3. Rendering takes a snapshot in time. Rendering means React is calling your component function. The result of that function is a snapshot of the user interface at that moment in time. The elements, properties, and event handlers you define are all based on the state that existed during that particular render. Think of it as React taking a photograph of your component. That photograph, or snapshot, contains everything React needs to display and interact with your UI for that moment. When React re-renders a component, it calls your function again. The function returns a new snapshot of the UI. React updates the visible screen to match this new snapshot. Here's an important concept. State doesn't live inside your function. It lives in React itself, as if stored on a shelf outside your component. When React calls your component again, it gives you the current snapshot of that state. Your component then returns a new UI based on that snapshot. 4. State over time. Now, let's explore how state behaves across time. Imagine you click a button that calls the same state setting function several times in a row. You might expect the state to update multiple times immediately, but it doesn't. That's because all those updates happen within the same render snapshot. React only applies the state changes for the next render. It doesn't modify the current one. During a render, the state is fixed. Even if you call the function to update it several times, the value remains the same throughout the render. The next render will then use the new value. This explains why a counter might only increase once per click, even if you seem to update it several times in one event handler. Every render has its own fixed version of the state, and React always bases its updates on the snapshot from the moment that render occurred. If you visualize this, it's like every event handler being written using the values of the state at that precise moment. So even if you trigger updates multiple times, they all reference the same initial snapshot. 5. State and asynchronous code. Things get even more interesting when you combine state with asynchronous operations. Suppose you update the state and then use a delayed function, like showing an alert after a few seconds. You might expect that alert to display the updated state, but it actually shows the state from when the render happened. That's because, once again, the event handler was created using the snapshot of the state from that render. Even if React has updated the state by the time the alert runs, the event handler still refers to the older snapshot. This makes event handlers in React very predictable. You don't need to worry that the state will suddenly change halfway through the code. It's fixed for the duration of that render. Let's take an example with a form. Imagine you press send, and the message is set to be sent after 5 seconds. Then you change the recipient's name before those 5 seconds pass. When the alert appears, it still refers to the name that was in the snapshot when you clicked Send. That's the beauty of this model. It avoids timing errors. You always know what the state looked like when the user performed the action, because React ensures that state remains stable for that particular render. 6. Recap. Let's summarize what we've learned. Setting state doesn't immediately change values, it requests a new render. React stores state outside your component and gives you a snapshot of it each time your component runs. Each render gets its own version of the state and its own event handlers. Event handlers are bound to the state from the render in which they were created. The UI is always rendered as a snapshot in time, ensuring consistency between what the user sees and the underlying data. If you ever need to read the most recent version of state before a render, you'll use a state updater function, which is the next step in this learning path.